If x appears only once in your equation, think about peeling apart. That is, remove the outermost layer. What's the last operation that occurs? And then the next, you just keep unshelling the onion in a sense. Now, if x is written more than once in your equation, you're going to have to factor. So looking at 3 plus 5x equals 9x, let's subtract 5x on both sides. You have 3 equals 9x minus 5x. A lot of people are going to feel comfortable skipping this step, but I want to illustrate a certain point, which is why I'm showing this. Now, for the next step, I'd like to factor out an x on the right side. There's a 9x minus 5x, and you factor out an x. We haven't done anything to the left side, so we didn't do something to both sides. So we just copy down 3 equals. It's just using the distributive law sort of backwards, right? We're turning 9x minus 5x into the following. Factor out an x, so there's an x written outside parentheses, and then inside the parentheses you have 9 minus 5. Now most people aren't going to think about doing it this way. Most people are just going to say, oh, 9x minus 5x, that's just 4x by collecting like terms. I get that. That is true, but the thing is, collecting like terms, where does it come from? Well, the only real place, like ultimately where does it come from is this. It's from factoring out the variable. That's what's going on under the hood. It's the only valid way to think about what's actually going on. And often it's sort of like not thinking about all of the things that happen inside the hood of a car when it runs, when we just, crank the engine and just go. And yeah, there are times and places to do that, but it's also sometimes good to look inside and really dig into the details. The point is then that 9 minus 5 part simplifies to a 4. Again, most people are going to jump directly from 3 plus 5x equals 9x to 3 equals 4x, collecting like terms and doing all this without writing. But the real point is the only reason why collecting like terms works is because you're factoring out the variable. Now we still need to, so we went from a situation where earlier, let me go back a step or two. In all the previous steps, like the ones shown in gray and the original question, there's 2x's written per line, and we went, oh, sorry, the last line in gray only now has 1x written. That's what factoring did for us. It went from having to write 2x's to only having written x in one spot. And so then 3 equals 4x also just has x written in one place. And now we can go back to this original principle of if x appears only once, peel apart. So we got 4 times x. To undo 4 times, we've got to divide both sides by 4. Again, this step, 3 over 4 equals 4x over 4. Most people are probably going to skip writing it, but I write this out just to really say there are all these things that are going on. It's just now 4x over 4, you can cancel the 4 times on top and bottom, so the right side is just an x, and you have 3/4 equals x. By the way, writing 3/4 equals x is just fine. When convenient, just leave the variable on the right side. You don't have to write x equals 3/4 unless you really want to. That is, for me, both x equals 3/4 and 3/4 equals x, those are equally correct as your final step of work. They say exactly the same thing, and that's really true for all equations in this class. You can swap the two sides of an equation, and you get, it will mean the same thing. So in the previous question, sorry to belabor this point, but it is that important. Turning 9x minus 5x into 4x involves a hidden step, and that hidden step is factoring, right? It's 9x minus 5x truly turns into 9 minus 5 quantity times x, which simplifies into 4x. Now it's fine to skip writing that 9 minus 5 quantity x, right? Then x outside parentheses. But you are required to know this. In this class, you are required to know that collecting like terms is really factoring out the variable. Otherwise, if you don't know that fact, I say that this is required. But if you choose to ignore this and you just try to not think about factoring out the variable, this next type of question looks very challenging. But if you keep in mind that collecting like terms is really just factoring out the variable, this question won't actually look that bad. So I'd like to reorganize this so that all the terms that have the variable are on one side and all the terms without the variable on the other. So you'll notice from the original question to the first line of the answer, what happened here was adding 9x on both sides and subtracting 3 on both sides. That's why there's a minus 3 on the right side. And there used to be a minus 9x on the right side, we added 9x to both sides. So on the right side, the minus 9x and plus 9x are gone. On the left side, since we need to add 9x to both sides, there's a 9x on the left side. It just to write it differently, it's not 9x, or rather 9 times x. I just chose to write it as x times 9. That's all. And then you can factor out the variable. On the right side, 7 minus 3, the arithmetic just turned that into a 4. On the left side, we did something different. We factored out x, right? So x root 5 plus x times 9 is the type of thing that people just tend to stare at forever and go, I have no idea what I'm supposed to do, and there's two written x's. But if you think about what we just did a moment ago, 9x minus 5x doesn't magically turn into 4x. The thing that occurred was factoring out x. So the same thing here. You've got x times a number plus x times a number. So why not do the same thing of factoring out an x? Just like up at 9x minus 5x, it's a number times x minus a number times x. So for the same reason, we factor out x. I want you to look at the work at the top where the bullet point is, 9x minus 5x, turning into 9 minus 5 quantity, then times x, then turning into 4x. I want you to see that in the same way as the left side, which used to say x root 5 plus x9, turning into x times quantity root 5 plus 9. I want you to see those as really the same process. And then to get x by itself, we've got x times this number in parentheses, not a particularly nice number, root 5 plus 9, but we can still divide by that number on both sides. And then on the left side, that will cancel. And so we end up with 4 over root 5 plus 9. Now, just to illustrate old principles, yeah, we have x equals a number, but this is a good time to say, look, for best practice, we ought to rationalize the denominator. So we'll multiply top and bottom by conjugate, root 5 minus 9, multiplied both on top and bottom. Who cares so much in the numerator what you do, but in the denominator, we should expand this out. 4 terms using FOIL. The inner and outer terms are going to simplify to a plus 0, and the root 5 times root 5 became a plain old 5, whereas negative 9 times a positive 9 became a minus 81. So in the end, the denominator is going to be a negative 76.